So sometimes you'll see a chemical reaction with the chemical formulas, and you'll have to balance that particular equation. But oftentimes you'll see it written out, and so you have to know how to understand these different word problems and write a balanced chemical reaction given just the chemical names. Okay, so you have metallic sodium reacting with liquid bromine, producing sodium bromide. You want to write the balanced chemical equation for this reaction. So you have metallic sodium and liquid bromine. So those are our two reactants. So sodium can occur by itself in nature, like the alkali, all of the alkali earth metals. And it's going to be found in the solid state. So you have sodium metal plus liquid bromine. So liquid bromine is indicating that it's in a liquid state, but I mentioned in class that there were 7 diatomic elements that these elements occur, right, as an atom bonded to itself in nature. And I said that those were all of the halogens, like fluorine, chlorine, bromine, iodine, and nitrogen, oxygen, and hydrogen. So those would be ones to remember. So you know that there are 2 bromines, and they're bonded to one another in this liquid bromine. This yields sodium bromide. Sodium as an ion has a +1 charge, and then bromine has a -1 charge. So they combine in a 1-to-1 ratio. Anytime you're forming something that is an ionic compound, you can just usually assume that it is, unless it's in water, in the solid state, in the solid phase. So you have sodium reacting with liquid bromine to produce or to yield sodium bromide. So let's balance this equation. So we're going to start with the thing that's the most complicated. Sodium bromide is the most complicated thing here. One thing that you might notice is that you have 1 sodium on each side, but there's 2 bromines on the reactant side and only 1 on the product side. So you need to add a 2 in front of sodium bromide. But now there are 2 sodiums. So you need to add a 2 in front of the sodium on the reactant side. And let's check and see if we have a balanced equation. You have 2 sodiums on the reactant side, 2 sodiums on the product side, 2 bromines on the reactant side, and 2 bromines on the product side. So you have a balanced chemical equation. Let's try another one. So this one says, write the balanced chemical reaction for the decomposition of barium carbonate into barium oxide and carbon dioxide gas. So decomposition just means breaking down. So essentially essentially carbonate is being broken down into barium oxide and carbon dioxide gas. So let's write this one out. So barium carbonate, Ba, barium is in group 2A, so it has a 2+ charge on it. Carbonate is a polyatomic ion that I asked you to remember, and this polyatomic ion has a 2- charge on it. So since we have something that has a 2+ charge and something that has a 2- charge, they combine in a 1-to-1 ratio. This is an ionic compound, and so I just told you, you can just, for now, write those as solids unless you're in water. This is broken down, so we write the reaction arrow, into barium oxide. Again, barium has a 2+ charge, oxygen has a 2- charge. So they combine in a 1-to-1 ratio. This is an ionic compound, so you can write solid, plus carbon dioxide gas. So you have all of the phases, and so now let's see if this is a balanced equation. So barium carbonate is the most complicated thing here. You have a barium on the left-hand side, a barium on the right-hand side, carbon on the left-hand side, carbon on the right-hand side, and then you have 3 oxygens on the left-hand side and 3 oxygens on the right-hand side. So this equation is already balanced. Let's try one more. So let's try CH3O CH3. This particular compound, you don't have to know its name. It's called dimethyl ether. So if dimethyl ether is a gas, and we want to write the reaction that is the combustion of dimethyl ether. So remember that combustion is when something reacts with oxygen to yield carbon dioxide and water. So let's write, CH3O, CH3. I told you already it was a gas because I wrote G next to it. So it's the combustion of this. If something's combustion, you're reacting it with O2. O2 is in the gas state. O2 is yielding, or this plus O2 is yielding carbon dioxide. Carbon dioxide is also in the gas state, and water. Now, if you're burning something, that water at first is going to be in the gas phase. Now, of course, at room temperature, this gas will begin to condense into the liquid phase, but in the moment of burning, right, it's going to be first in the gas phase. So I'm going to write water here as a gas. Usually water is a liquid, but in this particular context of combustion, we're going to write it as a gas. All right. So we're going to look at the most complicated molecule first. So the most complicated molecule is this dimethyl ether. It has 2 carbons. So I'm going to write 2 carbons on the right-hand side. There are 6 hydrogens over here on the reactant side, and so I'm going to put a 3 in front of this water. Now we have to look at the oxygens. On the reactant side, you have 1 oxygen in the dimethyl ether, 2 in the O2. So there's 3 total. And then on this right-hand side, there's 4 oxygens and 3 oxygens. So you have 7 total on the right-hand side and 3 on the left-hand side. So if you were able to increase the oxygen here to 6 total atoms, then with this oxygen from the dimethyl ether, you would have 7 on each side. So let's try that. And to get to 6, you would use the coefficient 3. So let's make sure we have the same number of everything on each one. So on the left-hand side, there are 2 carbons. I'm going to erase all of these real quick. Okay, and then you have 2 carbons. On the right-hand side, there are 6 hydrogens. On the left-hand side, there are 6 hydrogens on the right-hand side. On the left-hand side, we have 1 and then 6. So we have 7 oxygens. And then on the right-hand side, that's 4 and 3. We have 7 oxygens. So we have a completely balanced equation now. So I hope that this video helps people balance equations and come up with strategies to start balancing them a little bit better.